Alrighty, folks. Alright, here we are live. I am Cade. This is Ashley, of course. Thanks a lot for joining us again. I'm going to let Ashley kind of take it away and introduce what we got for you today.
All right, thanks, Cade. Welcome to our live stream. I'm glad you guys can join us here today. We're not going to be doing we just kind of made this decision, but we're not going to be doing a live stream every weekend, but instead we'll be giving you guys pre-recorded shows that you can view at the regular time, 2 p.m. time on Saturdays. We'll kind of switch it up. We'll have some pre-recorded shows. Sometimes we'll go live, but of course we'll let you know on Facebook. Another thing, so today's Saturday, so this Monday, on Monday we're going to have another Ask an Astronomer live stream with 2 of our PhD students. The theme for the Ask Astronomer show on Monday is going to be about stars, so stars and black holes. You can just come on in and ask any of your astronomy questions to us in the live comments. If you have any questions, you can just post them, just write a comment on the Facebook page as well. So we'll be cross-posting those videos to the observatory, the Race Observatory page and the Sky Theater page. So yeah, ask away. And on Wednesday, we have our trivia at 7 p.m. The theme for trivia on Wednesday is, what was it again? It was modern astronomy. So that's going to be 7 p.m. And of course, the winner of trivia will receive the meteorite in the mail. So we did get another collection of those in, and we have some more to give out. I actually have them right now in my personal possession, so I'm going to be sending those meteorites to you guys, to our trivia winners, and of course our donors. So if you donate $50 or more to the astronomy, our public programs, as well as supports our student employees. Will be substantially reduced because of just this whole thing that's going on. So yeah, we're reaching out for you guys for help. If you can't donate, just please like and share this video to your friends and family. I believe that is it. I think I've got everything covered, so you can take it away, Kate. Waiting for Kate.
Oh, even with our current levels of light pollution right now, we are going to be able to see everything that I'm going to show you here in Stellarium. What I did is I went ahead, because the mic was muted there, you couldn't hear me, sorry about that. What I did is all I did was open this Stellarium program, which is a free downloadable program you can get on your phone or computer. And then I opened up our date and time options here, and we are located in Denton, Texas, in the program right now. And you can view that by going to the left side of the window in case you don't remember from previous times of us using this. And you can change your location. We are facing the south, and I'm just going to kind of scroll out so I can kind of zoom out and see a bit more of what I'm looking at. I have it set to about 10:12, that's military time there, the 24-hour clock. And I'm going to just kind of click and drag to scroll around to look at the night sky in the north. The north is, of course, where we kind of need to look first to orient ourselves. And, of course, it is what we're going to be looking at whenever we are looking for Comet Neowise tonight, or really early in the morning. Unfortunately, Stellarium doesn't really show a good view of this comet. However, it is going to be very easy to see. You can see it with your naked eye, or you can see it with binoculars, or even a small telescope if you wanted. A high-powered telescope might be a bit much. It might be difficult to actually track the object if your zoom is too magnified. However, it's going to be in the northwestern portion of the sky, just below the Big Dipper, and crossing over the Big Dipper pretty much every day sequentially leading up to the 22nd of July. The 22nd of July is actually when you're going to be able to see it the best. And that is next Wednesday. You can look at it either early in the morning or around 10:30 or 11 at night. Early in the morning, from what I understand, is going to be the much better view, around 4 a.m. To 5 a.m. You're going to have a great view of it. Getting a little bit further away from light pollution might be preferred for some people, but for the most part, you should be able to see it even in a light polluted area, which is very neat. This is the brightest comet that we're able to see for the last 25 or 30 years or so, and this comet won't be making another pass by for at least 6,800 years, some reports have said, so that's pretty neat. In the northern sky tonight, of course, if you just look kind of directly north, which may be difficult to tell which way directly north is, but you can use, of course, the Big Dipper, Ursa Major, to find north. This group of stars right here is Ursa Major. I'm just going to hit the C button to turn on some constellations here. And this group of stars, this group of 7 stars, is in the constellation of Ursa Major. And the Big Dipper here is just kind of the back half of Ursa Major. Ursa Major was known as the Great Bear, or that is its Latin translation into English. And we can use these 2 stars as the pointer stars to actually send us directly towards Polaris, the North Star. So Polaris here, and I'm going to zoom in just a little bit, is an important star because, as you may remember and may know, it never rises and it never sets. So Polaris is actually a star that we consider our pole star. We don't have a South Pole star, just a North Pole star, and it's just this lucky point that our planet Earth is pointed at. As Earth, of course, is tilted out in space, it rotates around this tilt, this axial tilt of around 23.5 degrees. So every day, the Earth rotates around itself, and what happens is it's pointed up at this spot right here, Polaris, the North Star. And that's why Polaris is so important, is because as we rotate around ourselves, it looks like the only point in the entire night sky that doesn't move is Polaris. So we can kind of simulate that here. You can use the clock or the little fast forward buttons right here. I'll go ahead and pull up the date and the time. And you can kind of see here as I scroll through the hours of the night, Polaris stays basically still, and all of the other stars in the night sky will rotate around it. So that's kind of an important thing that has allowed us to track the night sky as well as stars and many other things throughout cultures over the last several thousand years. It's allowed our culture to really develop into what it is today just by keeping track of the night sky. So pretty neat. Other things that we're of course going to be able to see tonight, or maybe if you can't see Ursa Major because you're going out very early in the morning and you want to make sure you're facing north, you can of course, because it'll be early in the morning, you'll have a good sense of which direction the sun is rising in if it's getting close to sunrise. But if not, you might see something closer to this constellation right here. There we go. Cassiopeia, which is this little group of stars up here. It's another group of stars you can use to actually find Polaris, so you can use this kind of arrow right here to point you towards the general region of where you'll find the North Star. Again, if you're looking out for Comet Neowise either early in the morning or late at night, it should be fairly obvious to see. However, if not, I do recommend you using like a small or even a cheap pair of binoculars would help, and maybe driving somewhere a little bit outside of light pollution might help as well. But you can see it over even the Dallas skyline late at night right now, so it's pretty cool. Alright, so what I'm going to do now is I'm going to just zoom out a little bit here, and we're going to go from north to about east, and in our eastern sky, right now, we can actually see a bunch of cool things. Since it is summertime, our summer triangle is out, and the summer triangle is just this neat little nickname for these 3 really bright stars right here. They come from 3 different constellations, and you can see some of them are already labeled on my screen here. Altair is this star right here, and it's in the constellation of Aquila the Eagle. Over here to the left, or further towards, I guess, the north of there, is Vega, and then this one over here is Deneb. Vega is in the constellation of Lyra the Harp, and then Deneb is in the constellation of Cygnus the Swan. I'm going to go ahead and turn on some little art to show you these constellations, little representations. But these 3 stars right here are actually the brightest stars in the entire, well, summer sky that you can see. Vega is extremely bright. It's not the brightest star, not the brightest star in the entire night sky, but for right now, these are the brightest objects you'll be able to see. This little summer triangle is kind of an important little one that we can actually use, important nickname or important group of stars that we can use to help us find other points of the night sky. Cygnus the Swan here is also known as the Northern Cross. So Cygnus the Swan here, the shorter end of the swan, will actually point us towards the north, if you're still looking for Polaris or something like that. Further towards the south, over here, the summer triangle usually can also point us towards, or at least tonight, it can point us towards where we can find some planets. So if you follow the longer end of the summer triangle, it's going to point you towards the southeastern portion of the sky right now, and we can find Saturn and Jupiter. These 2 constellations are over here, closer towards where the Milky Way is. So if you're going out to see the night sky tonight or any time in the next week or so, if you look around 10:30, you're going to get a great view of, hopefully, the Milky Way. If you're far enough away from city lights and light pollution, you should be able to see at least part of the Milky Way over here, where we get the constellations Sagittarius and Scorpio. Scorpio is a really cool constellation. I like Scorpio a lot, because it's this nice big kind of J-hook, and it has a lot of different cultural interpretations without it actually changing shape. So this same exact shape, while it's seen as kind of the back end of a scorpion here, and in ancient times, these stars up here, which make up another constellation, Libra, they were actually seen as the claws of Scorpion. And so these stars right here, Zubin Akrabi, Zubin Eshemali, and then Zubin El Janubi, those are actually named for the different claws of the crab. Or excuse me, the scorpion, pardon me. And then, back here, you have this nice star, Antares. Antares literally means not Mars, and that's because Mars always passes right through here, and ancient people would try not to get them confused, or at least one tool that they use to not confuse them is by naming one of them, the one that's a bit more of a stationary and bright orange one, not Mars. And the way that you can tell the difference between a star and a planet, in case you didn't know, is that a star's light will be bright and will shine and shimmer, but a planet light will be just as bright, if not brighter, but it does not shimmer, it doesn't shine. Planet light, well, is a lot stronger. So planets are, of course, a lot closer to Earth than all of the stars out there, except the sun. But planets are reflecting back the sun's light. So that light is actually very strong, and by the time it reaches us, it's not going to be affected by our atmosphere, which is why starlight actually shines, is because light from other stars, by the time it gets to Earth, is fairly weak, and our atmosphere can actually cause the light to shimmer or shake, and that's how we get this nice twinkling effect that stars have. So over here, we have this nice hot spot in our Milky Way, and right here at the tip of Sagittarius here, if we look back at our constellation art, that's actually the tip of the arrow that Sagittarius is holding. Sagittarius in Greek mythology was this kind of medic and musician and military guy, kind of a specialist in a lot of different fields. Also part man, part horse. But the tip of the arrow right here actually is a place called Sagittarius A star. And we think that that is a location for a supermassive black hole at the center of the Milky Way galaxy. What I'm going to do here is I'm just going to turn on this little swirly button that's at the bottom here. This pinwheel shape actually represents a spiral galaxy, and this is turning on deep sky objects. So all of these nice nebulating clusters are, of course, pictured out here in the Stellarium program, which is very neat.
Hey, Kate, I have a question. No,
Go ahead,
actually,
Ashley.
not a question. It was Eric Nielsen from Facebook.
Cool.
He asked, when and in which culture were the constellations first named? It's a really good question.
Awesome. Yeah, that is a really good question. Thanks for asking that. I think you said Eric was the person who asked that question. So, lots of cultures, if not every single culture, but every major culture, has named constellations at one point. And it's going to be difficult, depending on who you ask, to say who named them first. We recognize here in at least the U.S. and a lot of parts of the world and in modern astronomy, most of the constellations you'll see come from Greek mythology. And that's just the westernized culture of the world and how that culture views it. Here in Stellarium, we can actually use, I want to say, it's either the sky viewing options or configuration, but I'm going to go to sky viewing options. And yeah, if you click on star lore here in sky viewing options, you actually have this huge list of cultures and different interpretations to constellations. So I'm just going to click Chinese here. And what I'm going to do is, that should have already been applied. I'll exit out of here. And now we have a whole new sky. A whole new sky filled with things that I do not recognize. Completely new shapes. So some people say that the Egyptians were the first people. This kind of answers your question better. Some people say the Egyptians were the first people to actually name the constellations, which adds up. That actually makes sense in terms of who developed calendars. Calendrical systems were probably going to be mainly developed kind of at the same time as these constellation systems, because that's what our calendar and our time was really based on. Is it was really based on what constellations, planets, and sides of the moon or phases of the moon we could see. Not sides of the moon, sorry, you can only see ever one side of the moon. I meant phases of the moon you can see at any given time. So the Egyptians and then also the Chinese could have very well done so at the same time, just because archaeologists and people who study ancient civilizations believe that those two cultures emerged at similar times and at similar pacings. However, I personally know just a bit more about Egyptian ancient civilization than I do pretty much any other ancient civilization culture. But I do know that Egyptians' culture's dates go back as far as 10 to 12,000 years ago in terms of the origins of their civilization and when the first pyramids were formed. The first pyramids, though, were just mounds. But there are a lot of different cultures that, for example, there's a place called Göbekli Tepe in Turkey that is currently dated to be about 13 or 14,000 billion years old, and it lines up with our actual our stars. It lines up with solstices. This temple does, and they have labeled, for example, Scorpion in a particular portion of the sky where you would most likely see on a solstice Scorpio. So the names of constellations, certain names, for example, Scorpius, could go back a very, very long time and could be shared amongst multiple cultures. However, we probably would say that Egyptians were more of the first to name things that are recognized in the Western sphere of astronomy. I hope that answers your question, or at least gets you more curious about that subject. There are a lot of different, and Scorpius is a pretty good example. In Maui culture, Scorpius is recognized as, I think it's called, oh gosh, I can't remember what it's called anymore, but it represents the demigod Moana from the movie Moana. It's a giant fishhook in the sky. So there are a lot of different cultural interpretations to the same shapes that we see. I do know one in China, for example, Orion is actually seen, or excuse me, not Orion, Taurus, the bull, is seen as a great tiger in Chinese astronomy. So it's basically the same face shape, but instead of a bull, they see a tiger, and then the body actually swells up in a different direction and connects with other constellations. So there are a lot of different, of course, interpretations to these shapes. These shapes, though, are very neat, and they've been important to us, and they were kind of our first TV. They were our first stories. We made stories up and attached them to these shapes to allow us to have different stories throughout the year, and of course keep track of the year and keep track of seasons before everything was written down or everything was in your phone, for example. So thanks for the great question. If anybody else has questions, feel free to answer them below. And if I don't know the answer to the question, I'll tell you that I don't know. I'm a physics student here and a physicist at UNT. However, I of course don't know everything. We do have our Ask an Astronomer events where myself and other astronomers and our PhD students answer questions on Mondays. And then, of course, we are doing our astronomy trivia on Wednesdays as well. And we can answer questions in any of those formats if you have questions about space or the sky or other cool stuff. All right. We are at about 2:30 now. We're getting closer to the end of our program for today. What I would like to do here is I'm going to show you one feature that you can use in Stellarium. I'm going to hit Control F, and we're going to see if we can go find where Stellarium says Neowise is. But I have a feeling that Neowise was, this is not going to be accurate just because the data that Stellarium is currently using, or at least this version of Stellarium is using, does not show where Neowise actually is. I think it's showing something else, maybe a different trajectory or an older version of data or something like that. If you were looking at the trajectories of comets in general, comet trajectories are huge parabolics. So if you've heard of in math, or if you remember a parabola, most of the orbits of planets, for example, are more circular. They're kind of like oval shape or egg shape. But for a comet, it's so small. Neowise is about 3 miles wide. So it's this kind of like a big chunky rock in space that's made of a lot of ice and a lot of other things. And what's happening is this thing is gravitationally bound to the sun. So what can happen is this giant comet will a lot of the times get on this huge gravitational pull where it actually swoops around the sun. And when it makes that big swoop shape, it's called usually a parabola or a hyperbola. And that just talks about the shape of its trajectory. It takes quick time to do one of these maneuvers, but then it takes another 7, 8, 10,000 years for it to continue flying in space before it goes back on the other end of its oval trajectory and gets looped back towards the sun and then towards us. And then what happens afterwards is a meteor shower a lot of the times. So whenever comets or meteors are flying through space, a lot of the times comets, when they pass through the sun, or pass by the sun, not through the sun, sorry. When they pass around the sun, they pass through Earth's orbit, and usually in front of us. So, and it's kind of hard to imagine here, but as we are moving through space, the comet has already passed in front of us, and there's all this ice dust and little rocks that it leaves behind. And that's the nature of a comet, is that it's melting constantly. It's like this big beard of fluffy ice that's melting away from this icy rock that flies through space. And all of this fluffy ice stuff kind of leaves a nice trail, and as Earth passes through it, all that trail actually falls to Earth in the form of little meteors, little meteorites, or a meteor shower, usually. It doesn't usually make giant or large enough particles, but a lot of very small particles in what we see as a meteor shower. And that's where we get the Leonids and the Perseids. Those meteor showers are basically left over from comet trails that kind of get left behind. So pretty cool. All right. The next thing that I'm going to show you for now is just one. Let's see here. Oh, I know. Here we go. I like to always at least show you some of the really cool images that Stellarium has loaded into its program. This right here is a star cloud, the Sagittarius star cloud. This is a vast globular cluster, or cloud of stars, and a cluster is usually a big grouping of stars that are all gravitationally bound. This is something on the order of tens of thousands of stars that are all gravitationally bound at the same spot, and they were usually all born out of the same pocket of gas. All through our Milky Way galaxy, and the closer you get to the center of the Milky Way, which is right around here, the closer you get there, the more torrential, of course, gravity is, the more chaotic things are. And that's why scientists sometimes like to say that Earth is just kind of chilling out in the suburbs in comparison to the rest of space, is because things get much more chaotic and disastrous for planets and stars as you get closer in towards the Milky Way. And it's really fortunate that we are in this perfect little ecosystem in our solar system that allows for beautiful events to happen like Comet Neowise, where we can see just this moment of an object kind of passing through our solar system and just saying hi for a little while. And, you know, civilization, the human race, would be completely different by the time that we witness it again. So it's very neat. That brings us closer to the end of our program for today. I am going to still be online if you have any more questions about things. What I'm going to do next here is I'm going to just transition our screens a little bit here. And I'm going to load up a vignette or a video that I'm going to find here of a comet. If you'll just bear with me, we're going to see what we can pull up here. But if you have any more questions, please feel free to drop them in the comments below. Besides that, I'm going to be pulling up a video here of Comet Neowise.
Hey,
Go ahead,
Kate.
Ashley. What's up?
So with the with Stellarium, when you download that at home and you try to look for Comet Neowise, like Kate said, it shows you like the 2016 comet. If you go into plugins, you'll just have to quickly download it. It takes like a second. It's really easy. I had to do this if you just like YouTube 2020 Comet Neowise Stellarium or something. It's a really easy plugin you can download that adds that comet to the program, so you can actually track it in the sky.
Awesome. Yeah, thank you, Ashley.
Yeah.
So if you download this plugin into your version of Stellarium, you will be able to see where Neowise is currently. Awesome. What I'm going to show you now is just some live clips that we have of Neowise, and they will be on your screen here in just a moment. All right, cool. And if you have any more questions or comments or anything like that, feel free to drop them in below the video. We'll be online here for another few minutes answering any questions you got. Thank you so much for joining us today.